Quick Guide to Modern Video Analysis Techniques for UAP and UFOs by Mick West, from the January-February 2025 issue of Skeptical Inquirer. The analysis of UAP, Unidentified Anomalous Phenomena, has become an increasingly mainstream activity. Years of lobbying by people concerned that UAP represent a non-human threat have resulted in legislation directing the Pentagon to study the topic. UAP were once called UFOs, unidentified flying objects, and most of the public still prefers that term. UAP was deliberately adopted in the 2020s to avoid the stigma around UFOs that has built up over the past few decades. The purpose of investigating UAP is twofold. First, we want to identify the object. If we can prove that a light in the sky was a particular plane, for example, then UAP is no longer an issue. Second, and more important, we want to detect anomalies. While UAP has anomalous in the name, for something to be classified as a UAP, it simply needs to be unidentified. Unfortunately, the name change introduced this ambiguity, and UFO would be more descriptive. UAP analysis attempts to demonstrate if a particular event was unambiguously anomalous, meaning it has no plausible natural or known human causes. It must pass the first test of not actually being identified, but must also demonstrate unambiguously that it does something like move impossibly fast, accelerate with impossible power, teleport, or defy gravity with no detectable means of lift. It's now a significant effort. Millions of dollars are spent on the All-Domain Anomaly Resolution Office, the Pentagon's new UAP investigation team. AARO works with other teams in the intelligence and scientific communities to analyze these cases. While the stigma of UFOs remains, there are genuine national security reasons for UAP analysis. Over the past decade, I have analyzed hundreds of UAP/UFO cases, often in collaboration with other interested people on my forum, Metabunk. During that time, we have developed informal best practices and a set of resources and software tools that have led to considerable success in identifying unidentified objects. While we have yet to find anything unambiguously anomalous, the reduction in noise from eliminating the identifiable should help surface such things if they exist. In recent years, increases in computing power, the easy availability of public datasets, modern image processing tools, and the increasing ease of coding solutions with open-source software and AI have brought us to a new era of UAP investigations, particularly when it comes to UAP videos. Here, I will give a brief overview of some of the key techniques we use that have proven useful in resolving cases. Fundamentals. The fundamental task of video analysis is to convert the sequence of two-dimensional images in a video into a useful representation of the real world. The first step here is to get the original video. This is overlooked surprisingly often, with analysis sometimes being performed on degraded copies that have either been downloaded from social media or have been shared as smaller files over email. Not only does this reduce the video image quality, it also sometimes removes individual frames or adds new ones. We often do frame-by-frame analysis, so we want all the original frames. Using a secondary copy also means you will be dealing with missing or corrupt metadata, often called EXIF, Exchangeable Image File Format. This is extra data that can be incredibly useful in analysis. In particular, videos often have a precise GPS location and a timestamp. When the video is shared, this data is often removed. Location is stripped for privacy reasons, and the timestamp is sometimes changed to the time the video was shared or when it was last edited in any way. Enhance or don't. Once you have the original video, you can create enhanced copies that can aid with analysis. The most powerful enhancement is usually stabilization. Videos are often taken by hand and sometimes from a moving vehicle. Stabilizing it can help determine what is real motion and what is simply the camera moving. I use Adobe After Effects for stabilizing, but there are several other tools. I will usually use feature tracking, meaning I track one point in the video, usually something in the background, and then stabilize it so that point does not move. Automated tracking might not work, as UAP videos are nearly always very poor quality. If they were better quality, you'd be able to see what the UAP was, and therefore it wouldn't be a UAP. You might be forced to do some of the tracking manually. This can be a tedious task, but spending half an hour manually frame advancing and moving the tracking point can ultimately save you a lot of uncertainty later. Feature tracking can also be used to extract information from a video. If you have an artificial horizon, then you can track the ends and record how the horizon angle changes over time. The video image itself might also be enhanced to bring out more detail. But here we come to one of the more annoying issues of modern video analysis: destructive enhancement. When you do simple enhancements such as adjusting the brightness, so long as you don't go too far, you will not destroy a significant amount of information. But more extreme adjustments to the brightness and contrast can look like they improve some areas, but they might blow out others. Avoid old-fashioned adjustments such as brightness and contrast, which essentially push everything in the same direction. Instead, use the more modern highlights and shadows functions, which expand and contract certain ranges of brightnesses without affecting others. For finer, albeit fiddly control, I often use the curves tool. Where you need to use a lot of caution is in using filters that actually change the pixels. These are things such as sharpening, edge detection, embossing, and upscaling. These can be useful for detecting the position of small moving objects, but they are generally not helpful in determining what those objects are. Embossing and similar filters will add pixels and create the illusion of an object lit from a particular direction. Upscaling, increasing the resolution of an image, will also add pixels, and with the advent of AI upscaling, it can invent actual details that simply don't exist in the original. Researchers unfamiliar with these problems have progressively enhanced video until they could make out extraterrestrial beings or the shape of non-human craft. Eliminating aircraft. One of the more common sources of UAP sightings is aircraft. In decades past, UFO researchers would have to call the local airports or even travel agents to try to determine what planes might have been seen. Now plane schedules are all online, and beyond that, we can now replay the flight activity over a certain area to see what planes might have been visible. This is possible because thousands of volunteers run tiny radio receivers that download the position data of nearby planes using a system called ADS-B and send that data to a variety of organizations such as ADBS Exchange, which then store the data. This allows you to look up the current positions of nearby planes or historical positions of planes anywhere in the world, going back 3 years or more. This is something I do several times a week and is a relatively straightforward process. 1. Find the time and location of the event. Convert the time to UTC format, essentially GMT. 2. Go to the link in the description of this podcast or on the article webpage at skepticalinquirer.org. Move the map over that location and set the date and time. 3. Find candidate planes. Basically anything in the right direction from 10 to 100 miles away. 4. Click on the plane, then in the left pane that pops up, export the KML file. Use geometric altitude. 5. Open the KML file in the Google Earth Pro app, a free download from Google. 6. Position the camera in Google Earth where the camera was and look toward the plane. If it matches what the video shows, then that's the UFO. In a recent example, a spotter near Cincinnati saw what looked like a triangle of 3 lights hovering over a building at 014 UTC on October 12th. I suspected this was 3 planes heading toward the camera. So I ran through the process above, and sure enough, there were 3 planes in a row heading straight for the camera location. Downloading the KML files and then dropping them into Google Earth Pro showed that those 3 planes would appear in the exact same spot as the triangle of lights. Public data? ADBS flight position data is one example of a publicly available database that can be used to examine historical events. There are many others that are often key to figuring out aspects of cases. Celestial objects such as stars, planets, and satellites can be viewed on sites or apps such as Stellarium. This allows you to see what the night sky would look like at any time from any position on Earth. Many UAP sightings are planets, bright stars such as Sirius, or satellites. Stellarium is clunky but powerful and accurate. Satellites can be tracked in more detail in sites such as inthesky.org, which is useful for checking if you're looking at Starlink satellites. The International Space Station is the most famous and largest satellite and is responsible for many UAP reports. There are several sites that track it, including NASA's Spot the Station And for historical positions, there's ISS Tracker. Weather is often a key component. Sites such as Zoom Earth or NASA's Worldview let you look at a satellite image of the weather on any given day. Earth by Null School gives historical wind, temperature, and other weather data in an easy-to-view map or globe. There are even databases for things such as lightning strikes, lightningmaps.org, and wind turbines, the USGS Wind Turbine Database. For an example of how databases like this can be combined to solve a UAP video case, see my Science Writers Convention talk, UAP Investigation with Public Data. A powerful technique made possible by modern technology is using complex queries on public databases. The prime example of this is Overpass Turbo, which allows you to query the OpenStreetMap dataset to find locations that match specific criteria. This can be very useful when investigating a UFO video with limited location data. In one example on Metabunk, a UAP video in Albany, New York, had a sign saying Plaza and a covered bus stop. Using only that data, a query to Overpass Turbo was able to locate 3 possible locations in a few seconds. Situation recreation. More complex reconstructions can be done using an open-source tool I helped develop called Sitrec. Short for situation recreation, this tool was originally designed to analyze the U.S. Navy videos Gimbal and Go Fast. It has evolved over several years to be a general-purpose platform for recreating, analyzing, and sharing typical UAP scenarios. Sitrec's analysis is based around the concept of lines of sight. A UAP video is two-dimensional, but you can use the information in the video and the additional data described earlier to create a set of lines of sight that indicate where the camera is looking at any point in the video. Once the lines of sight are generated, you can then create a path that traverses those lines of sight. You can create multiple paths, and each one is a possible solution to the UAP video. Paths can also be created by dropping in ADS-B data or using the numbers on screen to calculate view angles. For each path, you can then use Sitrec to calculate if the object took that path, how fast would it be going, what g-forces would it endure, and how big would it be. Those numbers would allow you to see if it was possible that the UAP was something mundane, such as a plane, or if the UAP is what ufology has been endlessly searching for, something unambiguously anomalous. Thank you for listening to Skeptical Inquirer Audio Edition. This podcast is produced by the Center for Inquiry at our headquarters in Amherst, New York. If you would like to support our work, please consider subscribing to Skeptical Inquirer magazine at skepticalinquirer.org. It is listeners like you that make our work possible. With your support, we can continue to promote science, reason, and secular values throughout the world. Thank you.